Get started. Welcome to another webinar session. Today we will review measurement aspect of research design. So I will cover chapter 3 and I will talk about a sample article to demonstrate. Finally, I will attempt to explain discussion 3 assignment below. So let's get started. So in this chapter, we're going to talk about the variables in our study. Previously defined the meaning of variable and how we are going to be measuring. You may remember in a typical research study, there are 4 aspects. There is theoretical framework, which you took a course on human learning and development. That's a good example. Statistical aspect. It tells you, it teaches you how to perform statistical tests. And then there is research design, this course. And finally, something you're not taking any class of, measurement aspect. So in a research study, we work with variables. And as you will see today, we are interested in operationally defining these variables. We're interested in putting these variables in a way that will allow us to collect data. And then we will analyze such data. The instruments being used, what kind of instruments are used, quality of these instruments, characteristics of these instruments, reliability, and to what extent we can trust our measure. Anything to do with measurement error goes in here. Okay. So today we will touch upon this measurement. So in a research process, we previously talked about literature review, creating the research problem, etc. The next step is defining our variables and measuring. As I said, I will demonstrate this with an example, hopefully. So third step is to determine a method for defining and measuring variable things. Remember, in methods of knowing, the method that we are interested in is the scientific method. In the scientific method, we systematically review information. We review information in an objective, in a way that the researcher is out of the question. So hence, we let data speak. If we want the data to speak, then we have to define a way, an objective way, to measure our facts. If the study is about procrastination, for instance, complicated psychological construct, then we have to come up with a way to measure that construct. So that's a difficult example. If we're interested in the connection between velocity and mass of an object, it's easy because both velocity can be measured easily, or mass, weight can be measured easily. So variables are characteristics or conditions that change or have different. They vary, and they take different values for different individuals in this. So in general, there are 2 types of these phenomena, these variables. One of them is well-defined, easily observed, and easily measured, like height and weight, velocity, things like that. You know, even though still there is measurement error here. If you want to measure height of a person, you can measure it in inches, and then 1/8 of inches, and 1/16 of inches, 1/32 of inches. more sensitive your measuring tool is, less measurement error you will end up. In reality, theoretically, you will never be able to free off measurement error. Nevertheless, this measurement error is not that significant. It's not going to make a huge difference in your study. In educational psychology, in social sciences, in sociology, in political science, in psychology, and such, the variables we work with are usually intangible. They are abstract attributes, such as motivation, self-esteem, or anxiety, or performance, or human intelligence. And we are trying to measure those uh, constructs. So therefore, because we are working on these, we created a different terminology to describe those. We call them a construct. In a theory, when we have a theory, I'll come back to this construct topic in a second. We define a theory as a set of interrelated, meaningful statements that attempt to explain. So the reason why you have a theory, you want to do two things. You want to describe a situation and you want to predict. We have a theory about cognition. Why? Because we would like to describe how an elementary school child thinking differs from middle school child. Okay? And hence, you have a theory. The purpose of theory is to understand, to explain, and then to predict. So a theory is about a set of interconnected statements. You have a whole bunch of variables. You study the relation among these variables, how they relate. What happens if anxiety goes up? What happens when self-esteem goes up? What happens when gender changes? What happens when a student's parents is coming from a different socioeconomic background? And once you have these interconnected relations defined, you have yourself a theory. So for in a theory, we use constructs. Okay? A construct and a concept, two things. Pretty much, we all are aware of what a concept is. We have an idea about a concept. In physics, in biology, we deal with concepts. Concepts are, tangible, phenomena that we study. When a concept is not tangible, when it's more trying to explain an underlying phenomenon, when it's deliberately created, we call it a construct. So pretty much we can say the following. A construct is a deliberately invented concept. By definition, every construct is a concept. By definition, every construct is a concept, but not every concept is weight the concept. Because it's tangible, it's observable, it's direct, it's a concept. Anxiety, on the other hand, is a concept. Yes, it is, but it also is a concept. Why? Because in a way we made it up. We made it up so that we can explain, we can create a theory. So in educational psychology, we work a lot with constructs. And because we work with the constructs, there is more measurement error. With a construct, comes larger measurement. More importantly, comes more disagreement among researchers. When we define motivation, different theories would explain motivation from different perspectives. You may remember from the human development course, some theories will even they won't even go into the concept, like Skinner's operant conditioning theory, because anything that has to do with inner mind, anything has to do with mind, at that time they called it a black box, and don't go in there. So the idea is, in educational psychology, we work with constructs. Constructs are complicated things to measure. Nevertheless, we have to come a way to measure these results. So a construct is hypothetical entities, deliberately made up concepts created from theory and speculation. That's how we build knowledge. Ultimately, our goal is to know about something. Okay? That's our ultimate goal. They cannot be seen. They're assumed to exist. Intelligence. You can't directly see intelligence. When you see two individuals, you don't necessarily understand one is smarter than you. They also help us explain and predict behavior theory, which is the whole purpose of it. So when it comes to constructs, so we have a variable in our study, and now we have to measure it. Comes with, there are two definitions that we are interested in. One of them is called constitutive definition, where we define a word by using other, pretty much dictionary. Very useful. That's how we expand our knowledge. For instance, intelligence is operating intellect or the ability to think abstract. Or you could say intelligence is an individual's capacity to deal with original problems. Defined with words. You are explaining one construct, one special concept with other words. Fine. This is useful. We need this. This will come from the theory. It's nice. It's a must. And we begin with this. But ultimately, we have to come with a way that, everybody, when they measure it, everybody will get something similar. That is called operational definition. This is very useful. Operational definition is when we define a word, in this case, a variable, okay, by assigning expressed or implied actions or behaviors. So we are defining a variable by assigning, this is pretty much definition of measurement. Measurement is assigning a number, an object, based on pre-established. So defining a variable in a way that it will lead you to an objective method of measurement. Example, we want to define intelligence in operational definition. We could say a 7-year-old child who successfully reads story is intelligent. In this case, your variable is a categorical variable, intelligent, non-intelligent, 1 and 0, dichotomous. And your definition is, if a 7-year-old can read a story, you call them intelligent. So no matter who is implementing the study, you can follow the same procedure and come up with similar results. Or even better, intelligence scores on Wechsler IQ test. So you could be defining, and this is more common, more useful, you could define intelligence as a person's score on a test, on an IQ test. This way, we operationally define. So, in natural sciences, physics, chemistry, biology, so on and so forth, we have well-developed theory, well-established theory. This is the real life, real world here, and our connection to the real world in the theory is pretty strong. You see these strong lines, they are solid, strongly connected to the world. Here you have the concept of, here you have concepts, C1, C2, C3, their concept. It could be mass, velocity, acceleration, cell, DNA, things that you could somehow observe directly. And these are directly with operational definitions connected to real life, strong way, and then they are connected to each other also in this. This is not in your text. It's a research classic book. It helps you to visualize. In psychology, on the other hand, let's say we have a small theory of understanding. This is from another textbook, Erlanger Lee, the best in the research design for doctoral students, common years. So here we have observable, and here we have our constructs this time, like figure drawing test, operational definition. We are going to have a construct here, and we will measure this construct with this test. And then we have an achievement, and then we have our operational definitions. Your score on an aptitude test, your score on an achievement test. That is the operational definition. And then these are connected to other constructs, and this connection is not as strong as you see. It's more vulnerable. There is less agreement on the strength. And then this RUC is your reliability score. Which we haven't talked about. So operational definitions, one more time, is methods of defining and measuring in an objective way. Variables that cannot be observed or measured directly. Example, intelligence can be operationally defined as score on an IQ test, and hunger can be operationally defined as the number of hours of food. You see, you can say hunger, somebody is hungry, very hungry, little hungry, or you could say how many hours haven't eaten. It's more objective, more measurable. That's pretty much operational definition. So when we attempt to do a research, and we're going to need our variables, obviously, and then we're going to have to operationally define our variables. The first thing you want to do is, unless you are the expert in the field, none of us is, you consult with the literature. You go back and you see what these researchers use. If you are one step ahead of this, as we will see in the article today, you can directly consult with theory, and then you can come up with operational definition. So in order to have to operationally define a variable, first there must be a theory. It doesn't come out of nowhere. It has to be a theory, preferably a well-established theory. There is a theory, like social cognitive theory, Piaget's cognitive development theory. Or classical conditioning theory. These are the examples that some of you are exposed to. Or it could be something you haven't been exposed to, distribution theory. Or a theory about something. Could be even smaller. So you have a theory. And then you have an instrument like a test, like a survey. It's not a test, like a survey, usually Likert scale survey, where you present statements, and then you ask students to rate themselves out of 5, out of 7, out of 10. You build in different measures. As, you know, so, and then once you have that, you have to make sure what you did is correct, reliability, validity check. For example, you want to know if test anxiety, I'm going to keep it very simple, test anxiety and math performance are related. That's you want to know. So obviously, first you are going to define anxiety. You are going to provide the theoretical definition, and then you're going to provide an operational definition. Okay? So for operational definition, you could say students score on X, Y, Z, whatever the name of the instrument we are using is, anxiety scale. That's how you define operation. So now we have test anxiety, same for math performance, but math performance it's easier, it's more common. You could say operationally, you could say students score on teacher-made test in such and such. You can be more specific. Now we, operationally defined our variables. 2 variables, and we've operationally defined them. Third step, once you collect your data, now that you have your scores, you can check for the reliability of the test scores. Not reliability of the test, the reliability of test scores. So let's move on. So we consult with previous research to determine the best way to measure the variable. We use the conventional way of measuring a variable so that your results can be compared to previous studies. Unless you are, leading research in the field, you don't come up with a brand new study. In fact, creating a scale like that on its own is a research study. So once you have your instrument, it comes validity and reliability. These are very big topics. Doctoral study, you may need to spend weeks on each study, each in depth. But basically, for our purposes, we will define what validity is, what reliability is, and what are good criteria to check on. So once you have your study, you check the quality of your instrument by checking the validity of it, and then reliability. So reliability, consistency. Reliability is consistency. Let's establish that first. Something that is consistent is consistency. It's consistency of test scores. Okay? So imagine a person. Imagine a person. You have a clock, a wall clock, and that clock is 5 minutes ahead. Every day, every time is 5 minutes ahead. It doesn't change. Always 5 minutes ahead. So that clock is reliable. It's not accurate, but it's reliable. You have a person coming to work, they always come work on time. 8 o'clock, they show up. 8 o'clock, they show up. You can rely on them. They're consistent. A person comes to work late every day, 5 minutes late. It's consistent. It's reliable. You can rely on their rate. A person comes to work one day early, one day on time, one day late. That is not reliable. So reliability is consistency. So if I'm giving a test to a student, supposedly I give the same test to the same student 100 times. Each time doesn't impact their next performance, supposedly, theoretically. The degree which these scores are close to each other. Now, theoretically, we can talk about this, but in reality, we're not going to go out and, test everybody more than once. But we have some statistical methods to to get some good information about the reliability of these. Every research article that uses measurement, they have to talk about the reliability of their scores. If not, it's a huge hole in the research. So reliability is consistency. Two scores, one from the new measures and one from well-established measure. You can do this in many different. One of them is, you have student scores on one scale, on one test, and there is another test students have taken before, measures the same thing. You can check the Pearson correlation coefficient between them. Then you can say if a student has high score on one and high score on the other, or a student who has a low score has also a low score on the other, then you can say these two instruments are positively related. And hence, your scale is in good direction. So there is positive and there is negative. Positive is when one of them goes up, the other one also goes up. When one of them goes down, the other goes down. Negative relationship is when one measure goes up, the other one goes down. Visualize this. We have two measures. So this is a student. Student has a score on test A and test B. You just chart them like this. If your data is lined up like a line, perfect relationship, which is not very realistic. It's not what you would come to see. But just to give you an idea, is positive relation. Negative is, as you see, look at person A and person B, these two people. Let's say this is test 1, this is test 2. Person A got a low score on test 1 and a high score on test 2. Person B has a high score on test 1, the opposite. Therefore, it's a negative. And when you have them all, like a circle shape, there is no directional relationship. This is directional, positive direction, negative direction, and this is. So we prefer to determine the consistency of a relationship, calculate correlation between two figures. Correlation, the word correlation, it was a chapter on statistics. You may remember that if you're taking a class. It's not a problem. I'm not gonna judge you. So co implies two things. Okay? How two variables are related. So for elementary school, kindergarten to fifth graders. Fifth graders. Think about their height and think about their reading. As they get taller, from kindergarten to 5th grade, their reading level goes up as well. So there's a positive correlation, but it's meaningless. It's meaningless. Why? Because the reason why they're better readers is not because they got taller. The reason is they got more schooling years, they got more brain cells, they got more neuron cells, they are exposed to reading. Nevertheless, there is a so the way to measure this correlation, we usually use Pearson's correlation coefficient. This is a topic of another class because we'll be referring this as a reminder. And it changes from -1, +1. We teach this to high school kids as well. You may remember from your high school years. And 0 means no relation. Pearson is Carl Pearson, a British psychometrician who lived 1890s to early 20th century. So in reality, the father of this Pearson correlation coefficient, Darwin's cousin, learned from Pearson he was a mentor to Pearson, but Pearson was the one who finalized the formula. The second quality of our instrument is validity. Validity is accuracy. Were to explain validity, one word, accuracy. You give your students a math test. In your test, you say, I'm going to be assessing your fraction skills. But there are questions from history. Obviously, this test is not valid. It's not measuring what it's supposed to measure. Yeah. So it's the extent which the test measures what it's supposed to measure. This is the definition I learned when I was doing my undergrad study. Word for word, something like what it's supposed to measure. Not a bad definition. The extent which test measures what is. If you give a math test, and in your math test, there is vocabulary the student doesn't understand. So you're measuring, in some sense, you are measuring the language skills. Your instrument is not going to be valid. So let's put this in more psychology. Think about something very practical. Wechsler IQ test. David Wechsler's IQ test. Intelligence scale for children. The most popular IQ test in American public. Number 1, by far. Created by a German immigrant. Right now, we have the 5th. So in this test, this IQ test, there are questions, there are items. It's an item. Some items are like checking the memory. So the test administrator repeats, provides certain numbers, and it asks the test taker to repeat them. This way, we're assuming that we're measuring test taker's memory. And we believe memory is a part of intelligence. If it is not, then our test is not good. Even something less concrete, even more anxiety. When we take test on anxiety, when we are interested in measuring a person's anxiety, We will give them a Likert scale, and you can Google anxiety scales. You will see many examples. In this instrument, let's say there are 10 statements, for sake of argument. And on these statements, you want the test taker to judge themselves from 1 to 5, like 5 being always, 1 being. And in those statements, what we're hoping is capture the essence of the anxiety as claimed by a theory. If we can capture that, our instrument is good. If not, we will have it. So it's pretty big, obviously. Without validity, your results are made. Measure validity. Okay. So is your IQ test, measure it accurate? How would you know? You will look at the items and you will look at concept of intelligence. You will look what extent. If, for example, your students are ESL students, your IQ test, they're heavily culturally biased, then your scores are not going to be. There are many different aspects of validity. Face validity, when you look at it superficially, it's your test measuring, like you are taking a test for a driver license. What you expect is you expect somebody to drive a car on actual street. Instead, if they are, driving on a computer, face validity, you can see it's not very great. Concurrent validity, where you get to check your scores against with a well-established measure. You want to measure your students' IQ score, you give them a non-verbal 20 test. It is an IQ test, deeper test of non-verbal intelligence, easier to administer. Then you can, if you have access to these students' risk test scores, Western IQ test, you can compare, see what kind of relation, if any, exists between. Then you can make a judgment. Predictive validity, construct validity, these are also part of validity. Read more about them. So what we want to know is when we measure something, this is the essence of classical measurement. When a student takes a test and their score is 70, okay, this is not their true score. Their true score is something different. If you give this test, maybe student was not feeling. Maybe student got some questions. Maybe student cheated. Maybe the room was too cold. Maybe student was lucky. At any rate, this is not the truth. And we will never know the truth. What we will know is the sum of true score and error score is wrong. This error score can be positive or negative. So overall, your true score can be less than 7, higher than 7. This is, a basic formula that we start with, and then, the classical measurement theory built on this. So this error, if we focus on this error, where is it coming from? Sources of error. It could be the observer error, like an essay. You're grading an essay, you're not grading it correctly, human error. It could be environmental factor. Room is too cold, room is too hot, so on and so forth. It could be the test taker just didn't have a good day, have a headache, or any individual factors. Studying this helps us to develop our theories. And remember, this is an introductory class, so we're just giving you at the end. And sometimes we give a test, retest. So we are in a position where we get to give things. And then we can check the Pearson's correlation coefficient between test and scores. This is, let me demonstrate how easy it is. With words, it sounds like it's complicated, but it's not. So let's say we give You have some students here. Say we have 10 students. You give them a test, form A, today, and next week you give them a similar test, form B. And these are their scores: 50, 60, 70, 80, 75, 90, 85, 80, 42. Whatever score they have, just randomly. Now I want to know, these two tests are measuring the same thing. Okay? I want to know if these two are consistent. I want to check the reliability. So I will check the correlation. And for that, I will go to data analysis in Excel. You can do this in many ways. And then you can go to correlation and then click on here. And then you choose your data. And then there are labels in the first row. And then OK. The correlation coefficient between these two is extremely 0.00. Remember, the highest was 7. Let's make this perfect. If I take this number and add the same thing all of them, and then perform the same thing, yes, do the same thing. Now I have perfect. See, now that I have perfect correlation, let's mess it up. Make this for this 60, and then this one 7, and do this again. Now it's 0.89%, which is still very, very high. So it's when we say this retest reliability, we're just talking about push of some buttons. It gives us a number between -1 and +1, and then we can make it. But the most powerful one comes from the, since we don't have a luxury a lot of times of giving the test more than one. What Holberg did when the measurement theory was very popular in the second half of 20th century, he took each item in and treated it as if it's one administration. And then he comes up with something called Cronbach's. And Cronbach's alpha, I write it down so you can spell it. You give test only once, but you get to check the internal consistency of test measures. It's basically, if there is a question that few people answer, so you consider that as a difficult. If a high scoring person is that question, that's not good for you. If a low performing student answers difficult question, it's not good for your life. It considers all these factors. And it's just, again, push of some buttons. There is a formula you can manipulate. Well, at the end, you come up with a number. And that number tells you about the quality of the consistency. So there is a relation between reliability. Test cannot be reliable if it's not accurate. Okay? So reliability is required for, can't have something be accurate and not consistent. If it's something is accurate, it has to be. The test scores are valid, they have to be reliable. But if they are reliable, it doesn't necessarily mean that well. The person is coming to work late every day, 5 minutes, you can say they're coming. They're consistent, but they're not. And finally, we have scales of measurement. Scales of measurement is when we have a variable, like our variable could be gender, our variable could be intelligence, could be math performance. Sometimes it's a category, like male, female, like ethnicity. Sometimes it's a score. Sometimes it's a rank. So it's good to know the measurement scale. The lowest level of measurement scale is called nominal scale. At nominal level, the values are qualitative, male and female. When your variable is gender, then your scale is nominal. Ethnicity, socioeconomic status, level of education. All of these are categorical. Ordinal scale, on the other hand, is in a competition when you get first place, second place, third place. If you receive, if you place third 2 times, it doesn't mean you're better than second. You can't add and subtract nominal scale. The difference between ordinal and here we can talk about some rank. One is better than the other. Being first place is better than second. But the distance between first place and second place is not same as the distance between second place. So, and then we have interval and ratio. These two are the same with one difference. They consist of series of equal intervals, unlike ordinal scale. The difference between each number is equal, and ratio scale has a true zero. But temperature, think about temperature, Fahrenheit or Celsius, 50 degrees and 60 degrees and 70 degrees. The difference between 50 to 60 is 10 degrees, and from 60 to 70 is also 10. But when you say 0 degrees, you're not talking about there is no temperature. True value of 0 doesn't exist. When you say 0 degrees, you mean to say it's very cold. There is also -1. So temperature would be an interval scale. A ratio scale, which is more powerful, so this is number 1, number 2, number 3, number 4. A ratio scale, there is like mass. When something's weight is 0, it means they don't exist. When height is 0, it means they don't exist. When velocity is 0, it means they are not moving. There is absolute 0 value. Therefore, they are ratio scales. We can add, subtract, find the mean, mode, or the interval ratio scales. Can't do that with nominal or ordinal scale. Right. So now I want to pause here and go back to this article. Okay. I posted this, optional. If you like, if you're interested, you can download this from the portal, the week 2, and read it. It's reasons, few reasons why I chose this article. Number 1, it's not very old. There are better articles, but they're in my archive. This is relatively new, 2008. Number 2, this guy, Zimmerman, is one of the leading researchers in social cognitive theory. And it's easy to read. These other studies are more complicated. This is much easier to understand. So first, you can read the literature. As we discussed last week, literature review, hourglass shape. Hourglass shape is something you start like this. Start with very generic stuff, and then you narrow it down. This is where your research question comes. And then when you talk about discussion and implementation, you try to generalize this. So mathematics teachers have focused on teaching essay, how generic it is. You can read this for yourself. And then self-regulation talks about the definition, theoretical definition of these topics. And then calibration of achievement. Calibration is when you when there is a gap between the accurate value and the observed value. As a student has high self-efficacy, a student thinks that they can get an A on a test, but in reality, they are a D. So there is a calibration issue. Bring them to the accurate point closer. That's calibration. And it's theoretically defined in here. I will focus on here, purpose of study. So the purpose of study will training students to use a self-correction strategy, check their answers, improve their self-efficacy, self-evaluation, and method. Let's talk about it. Let's take this paragraph, and let's see what we can do. So what we have is training students to use self-correction strategy. This is our variable, one variable. And this variable is categorical, 1 or 0. So typically, a researcher will have two groups of students. Because it's categorical, it will put some students here, some students over there. These students will be those who use self-correction strategy. We don't know what that is. We will see how their operation is defined in a minute. And these students will not use a self. But a lot of times this is called control group. This is called experiment. This is variable 1. Variable 1 is categorical. Categorizes our study into two. And then will this increase if we improve? So this is directional. So people in this group, people in group 1, expect their overall average will be higher. It's not non-directional. It's not like this. Took statistics. So will it increase their self-efficacy? I'm gonna check. So this is variable 2. And this variable is a continuous variable, numerical variable, self-evaluation. I'm interested in how we're going to define these operations, self-evaluation, and math performance. It's easier, nevertheless, it's one thing. And finally, self-calibration. This is the final variable. So overall, we have 1, 2, 3, 4, and 5 variables. 4 of them are continuous variables, numerical. One variable is good. So now let's move on and let's see how they are going to operationally define this. So the experimental study utilized a pre-test, post-test control. They're not there yet. I haven't learned about this yet. But they are randomly assigned. We'll know the significance of this later, future chapters. Training group or control? Fine. This is one definition of one variable. And then here are our measures. Math measure, self-efficacy. So we look at this. Researchers developed the self-efficacy measure. These researchers are, Zimmerman is one of the leading guy in the field. So they created the. So, but if you and I were doing this, we would go back and see what other published articles are using. We would be checking their reliability, of course, and we'll be choosing best one to our eye. This is how self-efficacy students rated their capability prior to solving the item on. You see, it allows us to replicate this. And same for self-evaluation, same for self-calibration bias, and math performance. Have our all 4 continuous variables operationally. It doesn't directly tell you word for word that this is the operational definition, you can easily say how they gathered the data. Now, finally, I want to go to, I would like to explain discussion 3 assignments and close the session. So in week 3, in discussion 3, I'm asking you to, right here, I'm asking you to define what operational definition is. It's in your textbook, it's simple. Don't copy the textbook definition, rephrase. And if you are working with a roommate, husband, wife, it's okay if you work together. I encourage you to do so. It's good. Come up with your own definition. Don't copy paste this. So this is easy. This is clear. Number 2 is create a research question, and I want you to make it very simple. Use 2 variables. Okay. Use 2 variables. Start using your own words and make it as simple as you can. Okay. The idea is to practice. Let's say you are interested in motivation and college exams, or motivation and GPA. You can say something like this: is student GPA related to their academic motivation? If you have time and you want to make this even better, consult with theory, some theory that you're interested in, and bring that into the, make it even more accurate. Something like this. This is a research. So, and it has 2 variables: GPA and motivation. GPA is a continuous variable from 0 to 4. It's limited. Therefore, it comes with some research design issues. And then motivation, you can check how motivation is measured with a Likert scale. There are hundreds of instruments. After that, provide operational definition of one variable. Use one variable. In this case, academic motivation sounds better, but you can go with GPA as well. Then you will say academic motivation will be measured using such and such motivation scheme. And if you make this even accurate in your own benefit, I have 62 students here, and so it's up to you. If you want to benefit from the course, it's up to you. If you make it more realistic, it's going to help you further down the line. So provide the operational definition of one variable. That's it. So I finished this in 2 lines. It's okay if you do the same. It's better if you elaborate and go more. Finally, discussion 4, there is a difference in discussion 4. You are going to describe 3 ethical principles of this Belmont report, and then you will describe purpose and responsibility of IRB. Now, this one requires 1 posting only. Normally, others, discussion 3 requires 3 postings. Discussion 4 requires 1. Discussion 5 will require 3. This is an exception from discussion 4. From time to time, I may use that to make it a little easy. In a long lecture, let's see if chat box there are any questions. My time is up. Right. Webinar link is already on the course website. I put it under the webinar assignment, webinar 2. like to join. It's also in your Teams calendar. It's in 2 places. And it's the same link every day, every week. So Nazgul, no problem. It's okay. You don't have to write a summary. If you are 5 minutes, 15 minutes late for the webinar, I don't mind. If you want to watch video, you can do so later, your own time. But you don't have to submit the summary. All right. Thank you very much for joining me. I'll see you next week.
Thank you.
I can take some questions. I'm gonna close, but if you have any questions, I'll stay here.
Yeah. Doctor, if you don't mind, in discussion